number 1 said to like draw the thing. So we kind of did it on our graph, and it started at 106 because the top of the tower is at 160. That gorgeous little thing right there. And yeah, so 160 and it has to go up. So.
And the soccer team wants to know how long it will take the rocket to reach the top of its trajectory and how high the rocket will travel and in how many seconds. They also want to know how long the rocket will be in the air.
We used Hannah's formula, H equals 160 plus 92t minus 16t squared, and plugged it in the seconds 1 through 8 using the formula so we could find the height of the rocket after t amount of seconds.
Here's our formulas. The 160 is the height of the tower. The 92 is the speed it's going up. And the 16 is like the gravity restriction or whatever. And then we just plugged in the numbers for t. We got 236, 280, 292. 3 seconds is the highest it gets. And then it starts going down, all the way down until between 7 and 8 seconds is when it hits the ground. That's all, folks.
Very good, group. Next.
Yeah.
Okay. We're still recording, by the way.
Oh, yeah. Okay.
All right. To find like how high the rocket went, we plugged in the formula of h in terms of time equals 160 plus 92t minus 16t squared, and we did that 1 through 8, and this is how our seconds that we got until we got to 7, which was 20, and we found that at about 7.25 seconds is when the rocket reached ground level.
Our graph makes a palabra. I don't know how to say it. Our explosion height was 292 feet.
The time to explosion was 3 seconds.
Our total time was 7.25 seconds.
Very good. Next. Jacob's group.
Not with the fizzle, but with the beta. Well, since we figured out our first formula that we got was HT equals 160 plus 92t minus 16t squared. And that was Hannah's formula. And what we found out was that H equals height, T is time, 160 is the starting height, and the 92t was the speed of the rocket per second, and the negative 16t squared was the gravity.
And then what we did was to get the graph and data table, it was plugged in as seconds, and then the amount was like a narrowing down over results to determine when the rocket hit the ground.
Okay, we saw that the rocket, or we knew that the rocket started at 160, which was the height of the tower, and it went up from there to 292, and that was after 3 seconds. That's when it exploded in the air. And after that, it went down and passed this line because that was off of the ground, and it went back down to hit the ground at roughly 7.14 seconds.
And then what we did was figuring out all of our plot points and everything. We just went to 10, and we found out that after 3 seconds, or at 3 seconds, it was the highest, which was up here. And then after that, it started decreasing, and that's how we knew that after this part, that's how far it would drop.
And after 7, we realized that it went to a negative, so the hitting the ground point would have to be between those two numbers.
Good work. Next. You're wasting video time, people. Your turn? Your turn? Your turn. Yay!
Okay.
So the first one says sketch the situation, and here's our graph. Our starting point was 160 because that was the starting height, and then we went up by 92 each time on the seconds. On the feet. Oh, and then number 2 says write a clear statement of the questions the soccer team wants to answer, and we are figuring out how long the rocket will take to reach the top and how long the rocket will be in the air.
Okay. And then for number 3, by plugging in the amount of seconds into the variable in the equation of h equals 160 plus 92 times 0 equals 16 times 0 squared, which is, well, that's the example. And then it's h is 160 plus 92, which the 0 is the t, and then you subtract 16t squared, and 0 on this example is the t again. And then for the first equation, we had h equals 160, which is the same as this variable, and h equals 160, and then h equals 160 plus 92 times 1 minus 16 times 1 squared, and we got 236 equals h. And h equals 160 plus 92 times 2 minus 16 times 2 squared. We got h equals 280. And then the highest height, which was 160 plus 92 times 3, subtract 16 times 3 squared, we got 292. And then after that, they started decreasing, because on the fourth times 4, we took 160 plus 92 times 4 minus 16 times 4 squared, we got h equals 272, and then from there it just started decreasing, and we just kept plugging it in. Yeah.
Okay, so we figured that it was 3 seconds because that was the highest one. So that was how long it took the rocket to get to its highest point, was 3 seconds. And then we discovered it would take 7.15, and it was like a longer decimal, but we rounded it to 7.15 seconds. It would stay in the air. So we discovered, and the equation we used to find that was we plugged 0 in for h. So we did 0 equals 160 plus 92t minus 16t squared. And we plugged in 7.15 for the t, and it equaled like negative 0.16. So that's when we rounded.
Good. My question for you is, you have that after 4 seconds, right here you have 528 feet, but then down here for 4 seconds you have 272 feet. So which one's which?
It's the 272 because when we did this one, all on the top one, all we were working on was how many seconds it took to go up, and we weren't putting the rest of the equation in it.
Interesting. Good job. This group.
Okay. So the first question is the sketcher situation, and we drew a graph for that. And at 0 seconds, our starting was 160 feet because the tower is that tall. And then to find out the rest of our points, we use the equation h equals 160 plus 92t minus 16t squared. So we just plugged in each second. We wanted to know the exact time to figure out our height. And then the soccer team wants to know how long the rocket will be in the air, how high the rocket will go, and how long it takes the rocket to reach the top.
We used Hannah's formula by plugging in the exact time we wanted to know, and then it would tell us the height of the rocket in feet. So when it hits the peak of the launch, when it will explode is at 3 seconds, and it will land at about 7.25.
So the rocket will be in the air from what he said, and the rocket will go up to 292 feet for the highest point, which is right there. And the rocket takes 3 seconds to reach the top. Those are our formulas. We took Hannah's and then put in the time to find these out, and then plugged everything in to find out the answers.
Very good. Good work. Next.
Okay, so for our work, what we did was, for T, we plugged in numbers. So we started out with 3, because that was a lucky number. And we magically found the top height, which was 292 feet. And then we went to 2 seconds to see if it would get higher. And we got 280 feet. And we found that it was decreasing. So 3 seconds was the top height, and then we went the other way and found 4 seconds, which was 280 feet, and then 5 seconds, which was 220 feet. The way we found that was h equals 160 plus 92t minus 16t squared.
For our graph, we knew that we started at 160 feet at 0 seconds, and we knew our highest point was 3 seconds at 292 feet. So any number before 3 seconds was the rising action of the rocket. So 1 second, 235 feet, 2 seconds, 280 feet, 2.5 seconds, 290 feet. And then after 3 seconds was the falling action of the rocket until it reached the ground. So 290 feet at 3.25 seconds, 280 feet at 3.5 seconds, and 220 feet at 5 seconds.
It takes 3 seconds to get at the top of its trajectory. The rocket's highest point is 292 feet.
And the rocket will be in the air between 7.25 seconds and 7.3 seconds before it hits the ground. And we guessed and checked by plugging in those random numbers into our equation.